Welcome to The Explainer. Today, we're going to talk about a pretty radical idea. What if the software that runs our entire world isn't really built at all, but instead it's grown? What if code isn't just a set of instructions, but it's actually a living, breathing thing? So let's really dig into that question because the answer could totally change how you look at every single app on your phone. See, you're probably used to thinking of software as something that's engineered, right? Like a bridge, it's designed, it's built, it's finished. But what if it's much more like a garden or a whole ecosystem that's constantly changing and evolving just to stay alive? To really get our heads around this, we have to look at this ancient symbol, the Ouroboros. Now, you've probably seen it before. It's the serpent eating its own tail, and it represents this infinite, self-sustaining loop. The snake literally survives by consuming itself. And in this new way of thinking, modern software does the exact same thing. And look, this isn't just some cool metaphor. It's a dead-on description of how massive systems like Netflix or Amazon actually work. Just think about Netflix for a second. The data on what you watch, that's the system's output. Gets fed right back into the system to generate new recommendations for you. That's the new input. It's this continuous, never-ending feedback loop where the end is always the new beginning. So what's the engine here? What actually makes this serpent move? Well, at its core, there's this fundamental tension, this powerful duality between two opposing forces that you can find in every single piece of software ever written. On one side, you've got the static nature. Think of this as the perfect, pristine blueprint of the code. It's the world of pure logic, strict rules, and its one and only goal is to be correct. But then, on the other side, you have the dynamic nature. And this is the messy, chaotic reality of that software running out in the wild, getting slammed by millions of users and all sorts of unpredictable stuff. Its only goal? To stay alive, to be resilient. And this right here is such a brilliant way to think about it. Every single bug you've ever run into, it exists in that gap between what the developers intended for the code to do and what actually happened when that code met the real world. But here's the twist. That tension isn't just where problems come from. It's also where all the value gets created. You know, this constant tug of war, it leads directly to something engineers love to complain about: technical debt. It's what happens when you take a shortcut to get a feature out faster. You're basically prioritizing the immediate needs of that dynamic, chaotic world. And that quick fix? Well, it becomes a debt you're absolutely going to have to pay back later, usually with a lot of interest, in the form of bugs and slower development. It's a ghost that haunts the project's future. Okay, so if software is really this wild, chaotic, living thing, how on earth do you control it? How do you keep the whole system from just collapsing under its own weight? Well, this framework gives us 4 guiding principles, kind of like the system's fundamental DNA. So you've got symmetry, which is all about creating order through standards. Then there's balance, which gives the system that resilience to handle stress. Unity makes sure all the different parts are working towards the same goal. And then there's paradox. Oh man, paradox is where the real magic happens. It's this idea that real innovation comes directly from embracing that central conflict. And that idea of paradox is so important because this whole framework, it doesn't just hand you easy answers. Nope. Instead, it shines a giant spotlight on the impossible choices and the fundamental trade-offs that software architects have to wrestle with every single day. I mean, just take the classic knockdown, drag-out fight between building a monolith, that's one single giant code base, and building with microservices, where you break everything into hundreds of tiny independent parts. It's a choice between 2 totally different kinds of complexity. The monolith can turn into a tangled mess, but microservices introduce all the chaos of the network. You're basically just picking your poison. So what's the way out? The Ouroboros model points to something else entirely: a fractal design. The idea is to build patterns that repeat themselves at every single scale. So a tiny part of the system has the same qualities of unity and independence as the entire system. It's a way of finding a kind of harmony inside the chaos. And this doesn't just apply to how you structure your code. It applies to other totally unwinnable trade-offs, like the legendary CAP theorem in distributed systems. This is basically a law of physics for software. It says that when your network fails, you can have a system that's consistent, or you can have one that's available, but you cannot have both. You get to pick 2, that's it. You are forced to make a sacrifice. Okay, so at this point, you might be thinking, A self-eating serpent? Really? Fractals? Why does thinking this way actually matter? Well, it matters because it takes all these abstract, high-level ideas and grounds them in the actual, concrete tools and practices that engineers use every day. And this is what's so cool. You can see how these big, philosophical concepts map directly to real-world engineering. Managing the loop? That's the entire point of DevOps and CI/CD pipelines. Taming complexity? That's exactly why we have tools like Docker to package software into neat little boxes. And embracing paradox? That leads to practices like chaos engineering, where companies like Netflix intentionally break their own systems just to find weaknesses. How wild is that? These aren't just buzzwords, they're strategies for tending to a very complex digital garden. And that brings us to a really crucial point. If software really is a living system that governs almost all of our interactions, from how we shop to how we communicate to how we vote, then the act of writing that code, well, it's basically an act of legislation. The choices developers and architects make become the laws of our digital world. So all of this leaves us with one last and pretty provocative question. If coders aren't just building static bridges anymore, but are cultivating these incredibly complex digital gardens that have their own emergent behaviors, what is their true role? Are they builders, gardeners, or are they actually becoming the legislators for our entire digital future? Something to chew on.